Good, good afternoon, everybody. Welcome back to another session of data science training from 360 Digit MG. We are providing this session, the trainers of 360 Digit MG are providing this session of free preparation for the interviews in data science interview questions. All right. And as part of that, one of the key things that we use is our mind map. Okay. And we'll be taking a random way in which we'll be doing this. All right. So I was just keeping the chat window ready. All right. Now, we have been discussing extensively about some statistics measures and etc. So today we are going to start with something related to statistics. Yesterday we concluded the session on that. So what is non-parametric tests? All right. And then parametric test. All right. So firstly, excuse me, you must be able to understand the difference between parametric and non-parametric tests. Tests conducted that follow tests conducted on data that follow normal distribution are parametric tests. All right. And the corollary non-parametric tests when we have established data is not normal, then we do parametric tests. Examples of non-parametric tests. Or better still, we can say about comparison of medians instead of means is one of the non-parametric tests. All right, that is what we do it. So Moore's median test. All right, anom. One sample sign test. So these are some of the things that we have learned as part of the non-parametric test. Okay. What is a chi-squared test? All right. What is a chi-squared test? All right. It is a non-parametric test. Now, when I say non-parametric test, distribution free, designed to analyze groups of differences when data is nominal. That is what the textbook definition is all about. It uses the contingency table for this purpose. All right. All right. The next question, like I said, we'll keep it totally random. The next question is, are dummy variables ordinal or nominal in nature? All right. Are dummy variables ordinal or nominal in nature? So now let me explain about this. I was just typing out so that after that I can explain about it. So whatever is the original data, that data is what we are going to be. Whatever the categorical data that we have, for that particular data, we are going to create the dummy variable. All right. So given this background, if I have, let us say, nominal data, categories that are nominal, then if I go ahead and do the one hot encoding, that is, I'm going to create multiple columns. As many number of columns, as many number of categories are there, or n minus 1 columns. If there are n categories to a particular variable, then it is treated only as nominal. It cannot be treated as ordinal because it is everything is independent. All right. However, if you are going to use the label encoding, whereby you are going to give a numerical entity to the various categories ranging from, let us say, 0 to n or 0 to n minus 1. If your original data has got, let us say, 11 different categories, a particular column has 11 different categories, then you can have 10 or 11 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can have these many numbers. Now these numbers may or may not be used as ordinal data, or can be used as nominal, or can be used as ordinal data. All right. So that is what we have to say. It can be nominal or it can be ordinal as well, depending on the usage. Now, however, the care needs to be taken when you are using it as ordinal data. All right. You have to ensure that the labeling is done accordingly, because the labeling by the algorithm is simply done on the alphabetical order. So that is why in certain cases, in certain organizations, in IT organizations also, they have designations and the corresponding label. So we have E1, E2, E3. So what is your designation? I am E7. So this has been chosen. Now whatever, so all right, project manager, etc. When you have it, okay. So when you have such a scenario, now if you go by alphabetical order, so P is going to be the first, S is going to be next, P and P are going to be first, and T is going to be last. So this is going to be incorrect. So that is why they will define the variable, the category itself as E1 software engineer, E2 project lead, so that it gets sorted in the ascending order. So little bit of pre-processing, manual pre-processing has to be done, or some kind of mapping has to be done if you want to use it as ordinal data. All right. However, the usage of ordinal data's modeling is very limited. Most often than not, when we are doing modeling, especially when you are doing predictive modeling, it is generally nominal data, binary data, continuous data, or even count data for that matter. Now, continuing our discussion with reference to the dummy variables. What is the need for converting dummy variables to numeric when dealing with SVM algorithm? All right, what is the need for converting dummy variables to numeric when dealing with SVM algorithm? Now remember, SVM is understood as a model. Let me put it in okay. SVM as a classification model. All the attributes have to be plotted in n-dimensional space. Turing parameters like need numerical values for computation. So therefore, we need to have all the values in numerical entities. All right. So that is the need for converting the categorical data into numerical format. While on the discussion of a regression model, we were discussing about SVM, and we know SVM can be both classification and regression. So while on the discussion of regression model, what type of data is best suited for tree-based regression? All right. All right. So let me give you the answer. Data that is not normal tree-based regresses. So when data is normal, what do we do? All right. These are some subtle information that is not known. All right. People know where, do you know decision tree regressor? Yes, I know decision tree regressor. Do you know KNN based regressor? Yes, I know KNN based regressor. All right. But many people do not know when to use what. And this is essentially what it is. All right. Okay. Now that we are talking about regression, all right. What is an index plot? All right. What is an index plot? Is something that is plotted serially. All right. Against the number within the sample. Okay. The data could consist of original observations or some, some kind of derived measure. All right. So let me type it out. All right. Or some derived measure. For example, residuals and predicted values. All right. Residuals and predicted values are one such example when we have the plot. Right. Now that we have understood what an index plot is, what is an influence? Sorry. What is an influence index plot? All right. What is an influence index plot? So let us see. So influence index plot is something that is related to the regression model. All right. And it provides the index plot. All right. It provides the index plot of the influence of the related diagnostics for the regression model. Right. So there you go. I, of course, mentioned it as a command here. You can say influence index plot. That is what it is. Continuing our discussion with the concept of regression and predictive modeling. All right. The next question is, what is a step forward feature selection? All right. What is a step forward feature selection is the next question. So this is a slightly detailed explanation. So basically, in the first phase of the step forward feature selection, the performance is evaluated with respect to each feature. The feature that performs the best is selected from all the features. This is the first phase. All right. All right. In the first phase, the step forward selection, the performance of the classifier is evaluated with respect to the feature. The feature that performed the best is selected. In the second phase, all right, what is done is the entire feature is tried in a combination with all the other features, and the combination of two features that yield the best algorithm is selected. All right. So first we take one by one. All right. And every single one of them, that is the keyword. Okay. We are looking at it and evaluating. In the second phase, the first feature is tried in combination with all the other features. So x1 with x2 or x1 with x3 or x1 with x4 or x1 with x5, so on and so forth. It is tried, and then the two features that yield the best algorithm performance is selected. So that is the combination. Now that is continued with x2 with all the other values. Similarly, x3 with all the other values. So all the combinations of two are taken into consideration. All right. All right. So this is with reference to the step forward feature selection. Now, obviously, the step backward feature selection may seem to be pretty straightforward, but it is not the case. All right. It is not the case. So let us try and understand what is step backward feature selection. Okay. This also is a stepwise process. So in the first step of backward feature selection, one feature is removed in the round robin fashion technique. All right. So removing one and looking at the n minus 1, then removing one more and looking at the remaining n minus 1, then removing one more and looking at the remaining n minus 1 till we are doing it n times. All right. So every time one is removed and we try to look at the performance classifier, predictor, whatever it is, which of those n combinations is going to work, given that there are n number of features. All right. So this is the first step. Now obviously the second step. All right. So in the second step, all right, in the second step, what we do is we remove two features at a time. All right. Once when we have removed all the features from the subset of those, all right, from the subset of those, we remove one more feature. All right. And the process continues. All right. The process continues till the specified number of features remain in the data set. All right. Number of features that we want are left over. Now there is a method, or what is the criteria? All right, what is the criteria for feature importance? All right. So there is something called as the node impurity. All right. Feature importance is calculated as where the decrease in the node impurity weighted by the probability for that specific node. All right. So the explanation which you can quote is feature importance is calculated as decrease in node impurity weighted by the probability of reaching that node. That is one method of computing. And what about the probability? All right, what is the probability associated with that? So the probability of the node can be calculated by the number of samples that reach the node divided by the total number of samples. All right, so that is the okay. So that is with reference to that. How to check the influence of the various inputs in a regression model. So unit increase in by the factor of the said inputs coefficient. All right, theoretically speaking, unit, that is 1, increase in one of the input values will result in the output being changed by a factor of the said inputs coefficient. That is what it is. All right. with a polynomial form regression, the R square value with the R square value was 0.82, what would happen if I choose for the same data poly is equal to 5? All right, what will happen to the same data if I choose poly is equal to 5? With more features added, the model increase in quality I shouldn't say will, I should say may also lead to overfitting problems. All right. What are methods of all right, what are the methods of improving the? So one of the common ways address the influential records. All right. Transformation to make the data more normal. Polynomial form. Adding features. feature engineering. All right. These are the methods by which we can improve the model. All right. Absolutely right. So continuing the discussion, one more question. Does not work very well for non-normal data. Sensitive to outliers. Tends to go extremes. All right, tends to go extremes of overfit and underfit. All right, so these are some. There are a lot more disadvantages of. Why is regression not used for survival analysis? Data pertaining to time to event analysis is okay, is not advised. Now, why is Why is linear regression not advised for time series data? A linear regression model works best within the lower and the and time series is therefore regression is not advised for time series analysis. Is it clear, friends? So this is in essence what we have, all right, for our discussion for today. We'll discuss many more questions in the future. Request you to please continue to follow us on our YouTube and all other social media channels. Many more such content will be coming. All right. Thank you so much.